Welcome back to our Azure Functions series. In this video, we'll configure triggers and bindings, walk through creating a function app in Azure portal, take a quick look at the configuration files, and wrap up with a live deployment to Azure. Starting with triggers. In Azure Functions, triggers are the foundation of how function get executed. They define what starts your function and when. Azure offers a wide variety of triggers, each designed to cater to specific scenarios, making Azure Functions incredibly versatile for different use cases. Let's start by breaking them down one by one, beginning with the Blob Trigger. This one is super handy if you're working with Azure Blob Storage. Imagine this. Every time a new file gets uploaded, whether it's an image, a CSV, or even a log file, this trigger jumps into action. It's like having a digital assistant that says, "Hey, there is something new here. Let's process it." So what can you do with it? Well, you could automatically resize images as soon as they uploaded. Or maybe you are working with data. This trigger can process those CSV files and push them straight into your database. And if you're dealing with logs, it's perfect for analyzing or archiving them. Next, let's talk about the Cosmos DB trigger. Think of this as your personal assistant for keeping track of database changes. Whenever something new is added or uploaded in your Azure Cosmos DB container, this trigger springs into action. What can it do? Well, say you're synchronizing data to other systems, it can handle that effortlessly. It's also great for running analytics for fresh data or sending notifications whenever there is an update. Now let's talk about the Dapr, Distributed Application Runtime Publish-Output Binding. This is all about making communication between your services seamlessly. With this binding, you can send messages to a Dapr-enabled component, perfect for creating a pub/sub messaging system. Why is it useful? Picture this: you need to publish message to a queue or topic to notify other services, whether it's for triggering workflows or enabling inter-service communication. Dapr has you covered. Let's move on to the Dapr Service Invocation Trigger. This one is useful for microservices. It allows your Azure function to receive requests from other services using Dapr's service invocation. What is the big deal? It makes calling one service from another incredibly straightforward. Whether you are creating APIs or handling inter-services requests, this trigger makes it simple. Next up, we have the Dapr Topic Trigger. If you are building a pub/sub system with Dapr, this is your go-to trigger. It listens for messages published to a specific topic and lets you react to them. What it's good for? Think about processing events in a distributed system or handling actions like order creation or user registration. Here's an example. You subscribe to an payment process topic, and when a message arrives, you kick off your shipping workflows. It's all about making this happen automatically. Now let's talk about the Event Grid Trigger. This one is all about event-driven architectures. Whenever an event occurs in Azure Event Grid, like a blob being created or a VM status changing, this trigger is ready to act. Why would you use it? Maybe you want to update a database with metadata when the new blob is created, or trigger workflows when custom application events occur. Let's not forget the Event Hub Trigger. This trigger listens to Azure Event Hubs for real-time data streams, making it a favorite for telemetry, logging, and stream processing. Imagine processing telemetry from thousands of IoT devices or streaming logs for analytics. This trigger is built for scale and speed. Here is one you probably use a lot, the HTTP trigger. This trigger runs a function whenever it receives an HTTP request, making it perfect for building serverless APIs. What can you do with it? Create RESTful endpoints, handle webhooks, callbacks, or basically anything that starts with an HTTP request. Next, we have the queue trigger, which is all about processing messages from Azure storage queues. What's it good for? Handling background tasks like sending emails or processing jobs asynchronously. Moving on, we have the Service Bus Queue Trigger. This one listens to messages in an Azure Service Bus queue. It's like Queue Trigger, but with some advanced features like dead letter queues and message sessions. When would you use it? Think enterprise messaging when reliability is key, or managing workflows that require session-based processing. Next up is the Service Bus Topic Trigger. This trigger listens to messages in service bus topic, enabling a true publish-subscribe model, where multiple subscribers can listen to the same topic. What's it useful for? Broadcasting updates to multiple systems or implementing event-driven architectures. And finally, let's talk about time trigger. This is your go-to automating task on a schedule. Why use it? For things like running daily reports, cleaning up stale data, or sending periodic notifications. That should give you a vision of when and why certain bindings are used. If you're interested in any particular, check out the docs for details. Triggers define how your function starts, while bindings let it interact with other services. Think of them like pre-made adapters in Toolkit. They know how to connect your function to different Azure services seamlessly. You just plug them in, they do the rest. There is two types of bindings. Input bindings. They bring data into your function. In this example, we have an HTTP trigger function which receives a file with blob input binding decorator, up blob input. Here is common places where input bindings can grab data from. A file from blob storage, a document from Cosmos DB, a message from a service bus queue. The data from the input binding is passed as a parameter to your function. And output bindings, they send data out from your function. For example, writing data to a blob storage, sending a message to a queue, publishing an event to event grid. You define the output data in your function, and Azure handles delivery to destination. As in this example, to the new blob. Every function has one trigger, which define when and how the function is invoked. Triggers can also act as input bindings, passing data to your function when it runs. Alright, let's talk about host.json. It's your one-stop shop for configuring your Azure Function app. What can you do with it? Let me break it down. First, it's centralized runtime settings. Think of this as the command center for your app. With host.json, you can set things like retry policies, logging preferences, and function timeouts, all in one place. Second, it's customizable pair binding settings. Need specific settings for different bindings? No problem. The extensions section in host.json let you fine-tune configurations for blob storage, service bus, event grid, you name it. And third, it gives you control over host behavior. Finally, host.json isn't just about settings, it's about behavior. You can control how many functions run at the same time, adjust logging levels, or even customize file paths to fit your workflow. The next bit we need to cover is how you manage app settings in different environments. When you're working with Azure Functions, there are two key environments for configuring your app: local and deployed environments. For local development, you use the local.settings.json file. This file holds your app configuration settings, such as connection strings, API keys, or feature flags. When deploying to Azure, these settings goes into Application Settings section in Azure portal. This is where you define production-level values securely. Remember to use Azure Key Vault integration to manage sensitive data securely, instead of hard-coding secrets. And in the end, we'll find out how to deploy a locally created function to Azure using VS Code. To do this, go to Workspace section, click on the Azure Function icon, and select Deploy to Azure. You will be promoted to select a function app, link it to your subscription. If you don't have one, don't worry, let's create it. Provide a globally unique name for this resource. Choose a programming language and select a resource location, and voila, your resource with the function app is being deployed. Once the creation process is complete, click the deploy button again and select the function app you just created. That's it, you are all set. Now let's open the Azure portal to inspect what has been created. In the resources section, you will find the resource group containing the function app we created earlier. Let's open it. Here you can view a list of your functions, inspect them individually, debug, monitor, and add variables. Another important area to explore is the keys, which can be used for authorization. Settings area, where you can manage configurations related to your deployed app, scaling, logging, policies, etc. We'll cover these features in more details in upcoming videos. And with that, we are wrapping up this video. Stay tuned, hit the like button and subscribe to our channel for more content. See you next time!